First of all, one of the things I described was a net list. We're not going to talk much about the specifics of the net list, but it's one of the critical elements, and it's one of the steps that John Donne will take you through, what he calls net listing. So in this particular case, what I see, a very simple circuit with a battery, resistor, and an LED. If I look carefully at this circuit has 3 nodes.
Okay, so from that, we can gather that when it's going in and out like this, like a big line, and a small line, and a big line, and a small line, that is a battery. So we just draw this right here. That's a battery. Let's go back here.
Battery, resistor, and an LED. If I look carefully at this circuit, it's one of the steps that John Donne will take you through, what he calls net listing. So in this particular case, what I see, a very simple circuit with a battery, resistor.
Okay, so he calls this a resistor. So we can infer that a resistor is resisting because it goes back and forth. So the resistance is pushing the current back and forth. So we'll just draw 2 lines like this, going this way, another line going that way, and that's how we know that that is a resistor, because it's going back and forth, resisting each other.
An LED. If I look carefully at this circuit has 3 nodes.
He says LED. It literally just says LED, so I guess I'll say it inside the schematic. But I don't see anything else that would show us the LED, so we'll just leave that. LED, it'll just literally just say LED.
Nodes, right? It's got a ground node. It's got a node here between that battery and this circuit has 3 nodes, right? It's got a ground node. It's got a node here between that battery and the resistor.
So, a node. He says node makes you believe that these two working together are a node. And up here, he points at this area up here as a node as well. So, well, what that makes you believe is that a node connects 2 things together or is alike. So I'm just gonna have this as a point being connected together, and I'll just make a box for that and say that is a node.
And it's got a node between the resistor and the LED. So what I see is this guy defines a node. It's got a node here between that battery and the resistor, and it's got a node between the resistor and the LED.
So he said there's a node between the resistor and the LED. So this area right here, a node. So that backs up my claim that a node is connecting 2 things, because this right here is also a node. And I'll just put this right here, node, put this up here, node.
So what I see is this guy defines 3 nets, and you'll see in your designs these net names will appear on the wires that run around through the circuit. Okay, so you'll see names like this. What you have then is a net connections table down here. So what I see is this guy defines 3 nets, and you'll see in your designs these net names will appear on the wires that run around through the circuit. Okay, so you'll see names like this. What you have then is a net connections table down here. Again, I'm not going to go through the structure of this, but basically what this does is it describes how individual components in the circuit are connected via these nodes. All right?
Okay. So we see the net connections table, and you can tell that they're connected through nodes. So these numbers probably will connect with these nodes right here. We can already see these numbers 1, 2, 2, 1, and it probably correlates with what this is.
So this is one of the last critical steps as we do as we go from the schematic capture into the actual PCB design layout. Alright, so when we get to the PCB, itself, the printed circuit board, just to introduce some basic concepts, right? So the board itself is made up of a couple of different layers. What I'm showing here is a basic 2-layer board. The critical layers you have are the copper layers. These are where the traces are that actually are the wires within the circuit, right? That are connecting the different components in the circuit. In this
Okay, so he highlights the orange, and he says this is actually where all the circuits are. This is, let's go back here a second.
Traces are that actually are the wires within the circuit, right? That are
That's where the traces are. They're actually the wires in the circuit, okay? So we can show these as traces. There are the wires, and we'll have wires here. These traces are wires in the circuit. We'll have this as a circuit board.
connecting the different components in the circuit. In this
Connecting different components in the circuit, okay. So we'll have this right here as one component, and this right here is another component, and that is connecting all together.
2-layer board, then I have another one here on the bottom layer. So we'll refer to this as the top copper layer. Very often we just say the top layer, and then the bottom copper layer, or just the bottom layer. Between those is a dielectric material, which is essentially fiberglass, sometimes called the substrate. That material is referred to, that fiberglass material is referred to as FR4. And FR4 is, as I said, a particular type of fiberglass, has a particular dielectric, set of dielectric properties and such that can be looked up. So typically, if you look at a basic board, what you have is copper on the top and on the bottom of one of those pieces of FR4 substrate. Now, in addition, what most boards also have is this sort of layer on top of that copper. It's on top, both on the bottom and on the top, called solder mask. We'll take a look at that in a second, but what solder mask is basically a layer of insulation that sits on.
So solder mask. Let's come right here. Solder mask. Layer of insulation.
Top of the copper so that things won't touch each other. Basically a layer of insulation that sits on top of the copper so that things won't touch each other. And then very often,
so things won't touch. So what this solder mask does is create just a buffer zone. We'll just draw this out, a buffer zone, so that it won't touch. You can see, drew a buffer zone here, and that's what the solder mask does. It just masks it so it doesn't touch.
often what you do is you have a layer of silkscreen on top. The silkscreen is basically text that allows us to identify what the components are.
Okay. Silk screen. Silk screen text that identifies what it is. Okay. So let's watch that again.
It's R. It's R. And then very often what you do is you have a letter of silkscreen on top. The silkscreen is basically text that allows us to identify what the components are.
Okay. So having text to identify what components are, that sounds like it's like the user interface that really we use to navigate. So here we have a circuit board. We'll just have, text like 1, 2, 3, things that identify what they are, and that's a silkscreen.